Hi, my name is Dr. Stuart Adams. I work at Fera Science Limited as a Senior Analytical Chemist. We generally are analysing over 100,000 samples a year for routine analysis, routines, pesticides, veterinary medicines, mycotoxins. But in line with that, we also do specialised testing for food contaminants from food packaging. So we're looking to use a combination of routine analysis in combination with high-res LCMS technology, looking to identify what the potential problems are. And I sit between both. I do a lot of routine analysis, but I'm let out occasionally to do the more interesting stuff for the high-res mass specs. I've been working at Fera for 15 years, and when I started in my late 20s, we were 150 pesticides was a good sized pesticide screen. We're now heading 400 or 500 pesticides in single tests. So we're doing more analysis effectively for less effort due to the number of compounds that we've got. The whole industry is moving toward the multi-residue approach. We're getting more information out of each LCMS run, out of each GCMS run. You still do get targeted areas, but that's once you've identified a problem, you cut off and focus on it to provide the information for risk assessments to happen. We do a fair amount of screening, so when we get positives, we've obviously got a value that we want to confirm, and we need from the qualitative screen, we want an indication of what the level is, so that when we go back to do the confirmation testing, that we've got the right calibration range. So we're looking at how can qualitative information support the quantitative information. So in essence, we actually want to move the two aspects closer together, not to report two results, but to report the correct result in a more efficient manner for the laboratory. One of the challenges that we're facing as an industry is we all want quantitative information, but possibly at the same level of efficiency producing a qualitative one. Actually understanding the limitations of both is perhaps one of the things that the laboratories need to understand. If we're looking for presence-absence testing, qualitative is where we're heading. For quantification, what we're looking for is a good, reliable, accurate result. So we need to have documented evidence of why we think the method works. Is it conforming to the current guidelines that we're operating under? And understanding ourselves that different countries and different areas of the world have different expectations. I think one of the big areas in the laboratories, especially the laboratory that I work in, is efficiency. How quickly can we produce test results? How I envisage the future of laboratories progressing is the increasing automation. You see in certain areas that we've got automatic samplers for the equipment. We're seeing automatic extraction units. What I haven't seen a lot of is automatic sample preparation, taking the raw commodity in, preparing it ready for testing, and having a way to link up these three component areas. I think once we've got a unified system that links all three of the automatic areas, that's when we'll really see a higher throughput of samples for testing in the routine area, and the generation of more information to be assessed. I think where the scientist is going to sit is ensuring that the automatic system is actually working, setting it up, giving us the confidence that the results we're getting are correct, and actually interpreting possibly more of the data. As the automation grows, there'll be more data produced per sample, so we're getting more data for less effort put in overall per sample, decreasing the time that it's taking from the sample arriving at the laboratory to the actual final report going out to the customer or for projects to be finished. I still see the need for the scientists to be involved in the process, to actually understand what's happening and to interpret the data sets, which I envisage becoming more complex as time progresses.